Hello, algebra students. Welcome to virtual GED class. We are still working on our Algebra Essentials for the GED test. And today we will be combining like terms. This is such a key algebra skill. We have Annette with us here today as a student to make sure that I make sense. So first of all, when I say combine, what am I talking about? Well, I'm talking about adding and subtracting in algebra. Now, you might say, Kate, why do we need a new name for adding and subtracting? We've always called it adding and subtracting, and that's been just fine for us. Well, it's because once we get to the land of negatives, the line between addition and subtraction really blurs. Like, for example, one of these is an addition problem, -7 plus -6, and one is a subtraction problem, -7 minus 6. And yet these two things mean exactly the same thing. Think about it. This says I owe 7 of something, or I am in debt 7. I'm -7. And then I'm going to add to that, and now I owe another 6. If I had $7 of debt and added in another $6 of debt, then I would be in debt a full $13. Now that makes sense to a lot of students because they're used to adding, and they say, okay, 7 plus 6 would be 13. It's negatives now. It should be like this. But look at the next example. The next example says -7 minus 6. And what I'll have a lot of students do is they'll come to their side work and they'll say, hey, 7 minus 6 is 1. This must be -1. That's just simply not true. What does this mean? Once again, you can see me starting from -7. So it's like I'm starting with $7 worth of debt. And then my account balance is going to go down. We're going to take out of our account another $6. Well, guess what? If you're at -7 and you take out, you subtract another 6, you're still going to go all the way down to -13. Those two things are the same thing. And so that's what I mean about the line blurring a little bit between addition and subtraction once we hit negatives. And so we're just going to refer to the whole thing as combining, and everything we learned today will apply to both addition and subtraction. Now, if you're stressed out because you're like, I don't know anything about adding and subtracting negatives. Oh my gosh, she started with that. Yeah, breathe through that. We're not actually going to do that today by hand. We're going to do that with our calculator, just like you'll be able to on the GED. And the main skill we're going to focus on today is the algebra, because the GED math test is an algebra test. Okay, you guys, your calculator can handle computations, but you have to be an algebra ninja. So let's build those skills. So we said today we were going to be combining like terms, so it's important to understand like terms. Let's start with just terms, actually. Terms are things adding and subtracting. For example, if you had this expression, 2 plus 5 minus 3, it has 3 terms. A 2, a 5, and a 3 are adding and subtracting. Now, we're going to be looking at algebraic expressions today, so our terms are going to look more like this. 2x plus 5y minus 3x might be a great example. But nonetheless, whether this looks more complicated or not, it involves variables or not, this is still 3 terms, 3 things adding and subtracting. A 2x, a 5y, and a 3x or a -3x, 3 terms. Now, I said that we were going to be combining like terms. So what does it mean for terms to be like? It means they have an identical variable portion. When I use the word variable, Miss Annette, do you remember what that refers to?
Letters.
That's exactly right. So we're talking about our letters, but it's not just the variables themselves like X or Y. It is also the exponents on those letters. And I hope that you remember that exponents are those little floating numbers, those powers.
Square and cubed.
Exactly. Square, cube, 4th power, 5th power, so on and so forth. Now, in order to move forward, I want to remember the past. Did you know that you're not going to remember something new unless you can latch it to old information? That's how our brain works. It makes connections. No connection, no memory. So do you remember? Let's think about what we said addition was way back in our first lesson on basic operations. We said addition was putting together groups of the same kinds of things. And we talked back then about apples and apples and oranges with oranges. We're going to see that same thing today, not with apples and apples and oranges, but with X's and X's and Y's and Y's. Okay, so Miss Annette, let's harken way back to, I don't know, second, third grade. And I will argue that the skill we're doing today is exactly the same skill we did back then, even though we organize our work a little differently. So, weird question. You know, I love those. What is the best way to organize your work in order to add 257 and 32?
I would have the numbers lined up.
Yeah, how would you line them up? Would you do 257 with 32 over here, or maybe over here, or maybe over here?
Well, my preference would be the last one.
Those would make it really easy to make a mistake with your addition. This would be the way that your teachers probably taught you, and that most students would organize their work, and they would be wise to do so. But why? Think about what the issue is there. Like this is 2 what?
200.
Beautiful. And this is 2 what?
2 ones.
Beautiful. That's 2 ones. So I really wish it worked that way in real life. Wouldn't it be super duper nice if you took $200 bills and 2 $1 bills and all of a sudden you had 400? Hey, right. But no, it doesn't work that way. And similarly, the other one wouldn't work, right? Because this is 5 tens, like $50, 257. And this is 2 ones. We can't add tens and ones and somehow end up with tens. Just doesn't make sense. But we do add this way. Why? Because this is 7 ones and 2 ones for a total of 9 ones. And this is 5 tens and 3 more tens for a total of 8 tens or $80. And of course, if we only have 2 hundreds and we have no more hundreds, now we're going to still have 2 hundreds. So let's just flip through this and think about the same concept a little bit. So I'm going to ask you some simple questions, and they're not trick questions, okay? I really want to know. So, Miss Annette, what is 5 apples plus 5 apples?
That is 10 apples.
Not 10 apples? Just 10 regular apples?
Just 10 regular apples.
Oh, fair enough. All right. I'm going somewhere with this. How about this one, though? What is 5 apples plus 5 oranges?
Now, there we have a problem.
There we have a problem, Miss Annette. Break it down for me. What's the problem here?
Well, they're not the same. You can't add 5 apples and 5 oranges.
Thank you. What do you have when you take 5 apples and you add in 5 oranges? You have 5 apples.
5 apples, 5 oranges.
5 oranges. Yeah, not 10 apple oranges. Do they mush together and become a new kind of fruit? Nay. That's not how life works. So not to pound it home, but let's pound it home. So what is $5 plus $5?
Now that's $10.
That's $10. Okay, but you probably see where I'm going with this, Miss Annette. Oh, what's $5 plus 5 cents?
$5.05.
$5.05. Now there's more than one way to write it. I could write it like this, which literally actually does say $5.05 of a dollar, but none of us say that. We do a conversion in our head and we say, what do we say? $5 and 5 cents. Exactly. So now we're going to take that pattern and we're going to apply it to X's now. And our first reaction might be to panic because it looks so weird. But think of those X's like any of the other things we were doing, apples and apples, or dollars and dollars. So then what is 5 X's? Imagine you have a bowl full of X's, just like you had a bowl full of apples. And then you come and bring in another 5 X's. A nice little bowl full of X's. So we're so glad our X's don't come in bowls. That'd be a rough day if you brought in a bowl of my X's.
You and me both.
Okay, but I have 5 X's. I bring in 5 more X's. What am I going to have?
10 X's.
10 X's. Brilliant. Look at you. You didn't need to memorize rules of algebra. It just made sense to you. But now let's compare that. Now I have 5 X's and 5 Y's, like having 5 apples and 5 oranges. What's going to happen now? Well, I can throw them all in the same bowl, but I'm still just going to have 5 X's and 5 y's. Whether in 2 separate bowls or they're together in the same bowl, they're still x's and y's.
If you were to add them 5x plus 5y, would the answer be 10xy?
No, just like it won't be 10 apple oranges.
Okay.
Or it wouldn't be $10 cents. It's 5 of some unknown number and 5 more of a different unknown number. I can't say, oh no, that's 10 now of the same thing. They're not the same thing. And that is the key takeaway we have to have today. If you remember nothing else today, I need you to take this away. We can only combine, and remember what combine means. We just said it means add and subtract, like terms, x's with x's, y's with y's, x squareds with x squareds. So like terms are things adding and subtracting with the identical variable portion. Like we said, the letter and the exponents on them are the same. We can do 5x plus 5x. I can perform that addition. That would be 10x. But if somebody asked me to add 5x and 5y, I can't do it. This is already as simple as it's going to get. Now, you're not going to have a problem just like this on the GED. They're going to ask you to add or subtract. But before we do, let's just practice the one skill, just identifying when they are like. First example, which terms from the bank are like with 3x? And remember what I said, we need to examine the variable portion. So not the first number, but the letter and any exponents on this letter. So this particular thing, it just has an x. So this guy is an x term. It is only going to be like with terms that have identical variable portions. So they have to have just an x as well. So obviously 5 doesn't have a letter at all, and neither does -11. But 3x, though, that's definitely like with 3x. That's easy. 3x and 3x, of course, they're like. But so is -4x. A lot of students will tell me, well, that's not like, it has a negative. Remember, I just said it's the variable portion. Doesn't matter what the number is out front.
Even if it's negative.
Exactly. Because you can add positive and negative numbers. That has nothing to do with it being unknown. It's that unknown portion, the variable portion that has to be identical in order to add or subtract them. So then do you see any other terms in this box that for the letter portion only have an x?
Negative x.
Brilliant. Absolutely. Negative x belongs in this list. Any others?
-3/4 x.
Beautiful. Let's not get panicked by negative signs or fractions. I love how you're ignoring things with 2 letters. X's and Y's are definitely not like. Plain old numbers, we call those constants, are definitely not like. Do you see any other term?
X.
Yeah, exactly. And I put that there on purpose because sometimes when things get easy, they are harder. But think of it, if you just had an X in a bowl, that's just a single solitary X. That's just one X over there. So you could have one X like having one apple, and 3 X's. You could put them in the same bowl and you'd have 4 X's. Those are like. Okay, awesome. And I'm also going to compliment you for not picking this one. A lot of people will tell me that 4x squared or 5x squared or just x squared are like with 3x, but an x squared is not the same thing as an x. Just like an apple pie is not the same thing as an apple. Next example says, which of the terms are like with -xy? Anything with an identical variable portion, so that is also an xy term, is going to be like. So do you see any terms that are like with -xy?
There's 7xy.
Brilliant.
64xy.
Gorgeous.
And 0.7xy.
Beautiful. 0.7 or 7/10 of an xy. Okay, next example. And I wanted to do this one because this is something that confuses students. It says, which are like with 1/2. And students freak out at the fact that this is a fraction, but it has nothing to do with whether or not it's a fraction. When we're talking like, we say that it has the same variable portion. We're talking about the letters. Well, look, there's no variable here. You're going to hear me say, and you'll hear your college math teacher say, that this is a constant term. It doesn't vary. 1/2 is 1/2 is 1/2 is 1/2. It's a plain old number. And so plain old numbers, whether they're fractions or decimals or negatives, are always like. They're all constant terms. If it doesn't have a letter, it's like, and it can combine. Now, you might say, I don't know how to add and subtract negatives and fractions. And again, that's not the point. Your calculator does, but you need to understand that they can be added. There's a way to do that. They are like.
When I was thinking which are like with half, I was only thinking -7/3. I didn't even stop to think about 5, -11, or 0.9.
They're all plain old numbers. So we're not talking, is it tricky? We're talking, is it possible? So is it possible to add decimals and fractions? Yeah, you have to do a little conversion. You have to do a little math. You have to make them be the same before you can do it, but at least you can make them be the same. Okay, last one. Which of these terms are like with -0.4x²? What is the variable portion of this term?
X².
Beautiful. Do you see any like terms, any other x² terms here?
5x².
Gorgeous.
And 4x².
Yes.
And 3/2x².
Good. Or 3/2 x². Same difference.
And x².
And plain old x². Beautiful. Even if it doesn't have a number in front, as long as the variable portion is identical, they are like. But why didn't you choose 3x?
Because it doesn't have a exponent.
It doesn't have the same exponent. An x is not an x², just like an apple's not an apple pie. They might be related, but they're not the same thing. This is the kind of math that you will be asked to do when you do the GED. Now, it'll probably be a little more complex than this particular example, but let's build our way up. So simplify the expression 3x plus 4x. I wanted to use this language here because a lot of times students see the word simplify and they think it has something to do with fractions. No, it doesn't. Okay, simplify is just that generic term. That means to perform any of those operations that you can perform. Make this sucker a little simpler. And I can add here. This is some number of x's and some other number of x's. Again, it's like I have a bowl with 3 x's in it, and then I bring a bowl with 4 x's in it. I can dump them all into the same bowl, and then I can say that I have a total of what?
7 x's.
7 x's. Now, there's another operation indicated here as well, right? Another way to think about this is 7 times x, but I can't do this math. I can't simplify this any further because I don't know what x is. I can't take some unknown number and figure out what happens when I multiply it by 7. So this is done. It's as simple as it's going to get. A lot of the time, the thing you guys struggle with in algebra, you want to keep going. You want to tell me what x is, or you want to tell me what 7x is, or you'll slip that equal sign in the middle just to make it make more sense to yourself. That's not what's going on here. This is not x is 7. This is just, I have some mystery number. He has not revealed his identity, but whatever number he is, I have 7 of him. All right. Now, I wanted to do some examples that get a little tricky. So this is the same complexity as the last problem, but it has some hidden numbers and maybe some computations we don't know how to do by hand. This says y minus 7y. Okay, girl, I'm going to date myself right here, but do you remember back in the day when they used to call a grand a G?
Of course.
Let's pretend like this said G's all along. We're going to make this make sense. So let's pretend you had a G.
Okay.
Okay? Nice. Your bank account's looking fat. But then
Yes.
you go and you spend 7 G's.
Oh.
So we know we're going to be in debt, right? We spent the G that we had, and then we spent quite a bit more, didn't we? And so that's the same idea here. 2 important things to realize. The first is the invisible number. That's just a single G or just a single Y. If it's freaking you out, put a little 1 in front of it. It's a G. It's 1 G. Mathematicians are so lazy. If there's just one of them, I just write that letter once. And then the second thing is you're like, I have gotten myself in serious financial trouble here if I only have a G and I spend 7 Gs. But some of us struggle so much with negatives, we're not sure how much financial trouble we're in. So do remember that you can use your calculator for the computations. Now, you can't use it for the algebra. Don't put the Y's in there. Don't put the G's in there. But you can use it for the computation, the numeric portion. So I'm going to have you do this in your calculator. What is 1 minus 7?
That gives me -6.
So you are going to have -6 of something. You're going to owe somebody 6 of something. 6 what? Well, when we were talking G's, if we had 1 G, like $1,000, and we spend 7 G's, spend $7,000, we would owe 6 G's. And depending on who we owed that to, we might get our kneecaps broken. We're doing street math today. I had one student, I can't remember what we were doing, decimals to fraction conversion or something, but he was such a ninja. And he was so bad at most math. And he's like, girl, I learned that slanging in the streets. Yeah, I told him, let's use our powers for good and not for evil, sir.
But, a lot of times it seems that we do understand it a little bit more when you're using it in the street. Just like the movie with the Latino gentleman.
Jaime Escalante. I've always wanted to be Jaime Escalante when I grow up.
The drug dealers in his class. And his way of teaching them was using what they knew from the streets. It was an excellent way to teach students. And they got it, and a lot of them moved on. Me, I understand it with money because I deal with money all the time.
And that's that thing we were talking about. If you can't connect it to something you won't remember it. So it would be better for you to think about converting grams to ounces for whatever nefarious purpose you chose to do that for, and learn that math. And then we can use those powers for good and not for evil. All right. Like good to get you an education, get your family out of poverty. I like that kind of stuff. I like legit ways to earn a living that don't end you up in prison.
Thank you, Kate.
Now let's look at our example where we're not talking G's, we're talking Y's. So we had 1 Y and we took away 7 of those Y's. We're not going to owe you 6 YYs or 6 XYs or 6 Y squareds. It's still Y's, just like it was still G's or it was still apples. If we combine the same thing, that variable portion is not going to change. You can combine the numbers in your calc, but you are going to keep the variable portions the same.
Is it always only adding and subtracting? Is it multiplication and division? Is that included with combining like terms?
No. And that's such a good question, because that's literally the line that you need to keep straight. We're starting today with combining like terms, adding and subtracting. Then the next 2 classes, we're going to look at what happens when you multiply. It's a different process. Just like when we learned in elementary school how to add and subtract, we might have lined them up the same way, but the process was very different. Adding, we did in straight lines. Multiplying, we passed out. And so same thing in algebra. It's going to be a different ball game. So it's important to know, what am I doing right now? Not just try to memorize steps. So don't get freaked out if the variable portions look a little scarier. As long as they're identical, we can totally combine them. So simplify the expression. And this time I have 8k squareds minus 9k squareds. So I have 8 of something, an ugly something, but 8 of him. And then I take away 9, or I spend, not, you're shaking your head at me again. She's like, you are in trouble again. Yeah, exactly. I'm going to end up with a negative number. Now to figure out exactly what negative number, do 8 minus 9 in your calculator.
It gives me -1.
It sure does. And -1 what? Well, we said the variable portion will never change. We're just gathering these things up. And so this is going to be -1k squareds. But I want to point out something to you. This is absolutely correct and right. There is nothing wrong with it. However, it is not simplified.
No.
I'm not saying we didn't do the subtraction. We did the subtraction, but we can write this a little simpler. Remember how I was saying that if I just have a G, I can just write a G. I don't have to write 1 G. Well, it's the same thing if I owe you a G. I don't know why you lent me that much money. That was not a wise financial decision. But you don't have to be, okay, you owe me 1G. I can count. I know I owe you a G. That would be a simpler way to write that. And so you can always drop a coefficient of 1. Well, coefficient is just the number out front. Now, that doesn't mean that G is 1. It just means that whatever G is, I just have one of him.
One. Okay.
So I'm going to write this expression a little simpler. I can just say that's the same as negative k squared.
Okay, so I will keep the negative sign.
Yes. We can drop symbols that don't make a difference, but symbols that change the meaning, I cannot drop those. It is a very different meaning that I have something than I owe it to you. Now, this is one that students get wrong almost every time. Directions say simplify the expression, and this is probably why you get it wrong, because I'm being a jerk. Again, simplify means perform the indicated operation. Make this a little simpler, but what I'm going to say is you can't. Why, Annette? Why can't I simplify this?
Because you can't combine them.
Exactly. They're not like. This is a J term. It's some number of J's. This is what we called a constant term. That's a plain old number. I can't have this I07 of some mysterious number that no one's told me how much it is, and then I add in $13 and now I know what it is together. I don't know what it is together. They're not like terms. I cannot combine them. This is already simplified. It's not going to get any simpler. There's no math I can do. Some students will think I'm like holding back on them. Like someday when you get like good enough at math, you'll learn how to do this. No, I can't do it. You can't do it. Nobody's doing it. This is as simple as it's going to get unless someone tells me what J is.
Know when to fold them, huh?
Yeah. Now,
oh boy.
Yeah. Well, this is why I gave you this one, because of the panic reaction with fractions. I'm literally trying to give you guys what they call exposure therapy in the world of mental health, right? When you have an anxiety disorder, they'll often expose you to something in small doses until you stop being so anxious. This is not a challenging example because your calculator will handle the numbers. All you have to do is the algebra. So what we're going to do is we're going to look for like terms. So first of all, let's just work on visually breaking this up into terms. So remember, terms are things adding and subtracting. I have this 2/3 k, and then I see minus 1/6 k squared. So that's a second term. So now I'm up to 2 terms. Plus 5/6 k, that's a third term, minus 2/3 k squared. That's a fourth term. Now, I can only combine like terms. So this term is a k term. Do you see any other k terms?
Yes, 5/6
Good. Now I want you to box that term with the symbol in front of, because if you lose the symbol, you're going to lose whether it's adding or subtracting. So this is 2/3 k plus 5/6 k. These are like terms, so I can combine them. Now, you might say, no, I can't combine them, Kate, because I can't add 2/3 and 5/6. And again, I would say you can in your calculator. To do that, I'm going to choose that N/D button to type in a fraction. Type 2 on the top, 3 on the bottom. I'm going to arrow out of that. Plus, I'll pull out another fraction and 5/6. And I get 3/2. Your calculator did the computation, but you have to know how to do the algebra. 3/2 what? That's going to be 3/2
k.
Brilliant. See, it's not hard. It's not a fraction test. We've gotten rid of these terms, but we have some more terms. The next term I see is negative 1/6 k squared. You say, is that a minus or is that a negative? And I say, But if you're starting with it, I'm starting in debt, negative 1/6. Do we have any other k squared terms?
Yes, there's a negative 2/3.
Gorgeous. Those two terms can combine. You need a negative sign out front, but then you're going to do minus 2/3. When it's in the middle, you say minus. So my negative is down here at the bottom, fraction bar, 1/6. Arrow out before typing minus up above the enter, fraction bar 2/3. And I get negative 5/6 and negative 5/6 what?
K squared.
K squared. Exactly. The variable portion will never change when adding and subtracting. Never. Now, I do need to let you know, though, that sometimes they won't write the terms in the same order as you do. It really doesn't matter. Think about it in life. If I owe you $5 and I have 7 in my account, that's the same as if I have $7 and I owe you 5. Order doesn't matter as long as you take your sign with you. I had a -5, this is minusing 5. I had a +7, this is a +7. We'll see the same thing with terms. I could have just as easily had this term first, -5/6 k squared, and this term second. Now, this was a positive term, so it would be +3/2 k. These two answers are equally correct. Neither one's any better than the other. You say, well, which one will I need for the test? The test will be multiple choice. So all you need to be able to do is say, oh, if they don't have my answer, oh, that means the same as my answer. Okay, you know what the main skill on this one is going to be? Breathing. You breathing?
Yes.
Exactly. So again, we see simplify. And again, we can see some terms. Here's 17j squared k. Next term is minus jk or negative jk. You can read it either way. What's my next term?
19jk squared.
Good. And the next term?
Negative 11jk.
Sure. Yes, you can read that as minus or negative. I'll accept it either way. Awesome. And the next term?
Negative 18j squared k.
Gorgeous. So consider our first term, 17j squared k. Do you see any other j squared k's? I need the entire variable portion to be identical.
Negative 18j squared k.
Absolutely. Pick up your calculator and do 17 minus 18 for me.
Well, -1.
Yeah, I have $17. I spend 18. I'm in just a little bit of trouble this time. So I owe you 1j squared k. Now, there's nothing wrong with what I just wrote, but it's not as simple as I could write it.
Yes, we can remove the 1 and just have negative j squared k.
Exactly. Now, if you struggle with algebra and kind of panic, it is a really good idea to use different colors or different shapes to look at your different kinds of terms. My next term is a negative jk. Do you see any other jk terms?
Yes, negative 11jk.
Beautiful. Now, this can be tricky to know how to type in your calculator. Negative minus 11? Negative what? It doesn't even look like a number. Well, remember that invisible coefficient. We can drop it, but we can also add it in if we're getting confused.
The 1.
And now you can type it in your calculator.
And that gives me -12.
Brilliant. Now, -12 what?
jk.
Brilliant. I've been borrowing JKs all over town. Awesome. Now, here's a term that has no like terms. There's no other JK squareds. And so you guys feel that panic start rising. Well, quell that panic. What do you do with it when there's nothing to combine it with? Well, you just stick it there. Is those oranges that got stuck in the apple bowl and I can't turn them into apple oranges, but they can sit there in the bowl. Again, know when to stop. Nothing is like, we can't do any more adding and subtracting. Okay, so let's take a look at an advanced application of this, and don't be freaked out by the word advanced. This is not actually a complicated example, but a lot of students won't learn what we call adding and subtracting polynomials until later in math, but turns out it's this exact same skill. So if you look, it says find the sum of the polynomials. Now, don't get confused by this language. As we know, sum just means things adding, and we can indeed see that we have this big ugly grouping adding with another big ugly grouping. Now, those groupings happen to be called polynomials, but polynomials means something with many terms, and we can see it. This first group has 3 terms in it. It's a polynomial. And this next group has 3 terms in it. It's a polynomial. I'm not asking you to do anything complex. I'm asking you to add these 3 terms with those 3 terms. And because it's just addition here, groupings won't matter. You can literally drop the parentheses with no consequences. I'm allowed to add in any order I want. I don't have to group up certain numbers to add together. And so I'm literally just going to rewrite this without the parentheses. This is the same as 5n squared minus 7n plus 1 plus n squared plus 8n minus 16. You have those terms and you have these terms. And now that those parentheses are gone, it looks just like what we've been doing. We know we can combine like terms. So let's look at this first term we have, 5n squared. Do you see any terms that are like with 5n squared?
Yes, n squared or
Beautiful.
1n squared.
You're right, exactly. If I just see a single solitary n squared, that's like I have 1 n squareds. So what would 5n squareds plus 1n squared be?
Oh, that's 6n squared.
Exactly. Let's look at the next term. Remember to keep it with its sign. That's a minus 7n or a negative 7n. Do you see any terms that are like with negative 7n?
Yes, plus 8n.
Gorgeous. What is negative 7 plus 8?
Now that gives me 1.
It does. Now, careful. It's a positive 1. So I'm going to write plus 1n. Now, this is absolutely correct, but I kind of look like an English major, not a math major, because a math major knows a simpler way to write this. How could I write this a little more simply?
Well, we can get rid of the 1 and just put plus n.
And now the next thing I see here is a constant term. Plus 1 or positive 1 is a plain old number. Do you see any other constant terms?
Negative 16.
Beautiful. So they can combine. We can do 1 minus 16.
And that, of course, gives me negative 15.
Gorgeous. And so I'll just write minus 15. And I'm done. No more like terms means no more simplifying I can do. Okay, so next example. Again, we're looking at polynomials, but this time it says subtract the polynomials. And again, we can see that, yes, there's some subtraction. This polynomial, this list of terms, basically 1, 2, 3 terms right there, subtracting with this polynomial, this list of terms. But there's something important to know when there's a subtract sign between them. When it says minus, you are subtracting the entire group. It's not just the 6p squared that's subtracting. It's 6p squared minus 6p plus 14. Groupings matter when we're subtracting. So we cannot just drop the parentheses here. We have an extra step. And that is you have to pass out the subtraction to the entire group.
And we leave the parentheses?
Well, in order to drop them, I have to pass out the subtraction because that minus sign outside of those parentheses means that everything in those parentheses is subtracting. So it's not just the 6p squared that's subtracting. It's also the negative 6p is subtracting. It's minus negative 6p. And the 14 is subtracting. I'll drop the parentheses on my first grouping with no consequences because there's nothing out front of these parentheses. But the second grouping, we're going to see every number change its sign. So yes, inside here, this 6p squared is positive. There's no sign in front. And so that will turn into negative 6p squared. However, that minus 6p is subtracting because it's in that group. It's minus a negative 6p. And as we learned in the Intro to Integers class, when you take away a negative or you subtract a negative, it becomes addition. And so we're going to see that negative 6p become positive or plus 6p. Every term will change signs when we drop the parentheses. So then this plus 14 will become minus 14.
But you didn't change the signs in the first group.
Okay, I love that. Take a look. There's nothing out front of the first group. It's not minusing. It's like that whole thing is positive. But the minus is in front of this grouping. So this whole grouping is subtracting. So this whole grouping, everything will change signs. And now that we've done that, though, guess what? It's just combining like terms again. Here's a p squared term, and I have another p squared term. What is my other p squared term?
Negative 6p squared.
Beautiful. Deal with the coefficients in your calculator. 4 minus 6 is?
Negative 2.
And I was adding and subtracting p squared, so I still have p squared. It's gorgeous. Now I have a positive or plus 5p. Do you have any other p terms?
6p.
Plus or minus?
Plus 6p.
Gorgeous. Can you combine the coefficients, the numbers out front?
That's 11.
That is 11.
Plus 11p.
Beautiful. We see that plus sign. This is a list of terms, things adding and subtracting. And now there's a constant term, a plain old number. Do you see any other constant terms?
Negative 14.
Gorgeous. Again, keep those signs out in front. This is negative 11 minus 14. You can go ahead and do that in your calculator as well.
No, that gives me negative 25.
Good. You're in debt $11 and you go and borrow another $14, girl. You're in trouble. You're in debt a lot. Stop glitching over the fact that it's subtraction and realize what subtraction means. It means taking away money. Well, if you're already in the hole and you take away some more money, your debt's not going to be less. Your debt's going to be even more. Okay. Can I combine any further?
No.
None of the terms are like, know when to stop. Now, this might look scary, but what I wanted to show students is that this skill even comes up in solving equations. Now, we've been simplifying, working forwards, not solving, working backwards. So students don't think these two playgrounds should come together. But guess what? We said the other day when we were working on more complicated equations that we were solving, that if you could, you should simplify the left and right hand side before you start solving. We said pack before you move. Now I can take a look at the right hand side of the equal sign here. There's nothing to do. It's not going to get any simpler. But on the left hand side of the equal sign, I have 4 terms. Do you see those 4 terms, Miss Annette?
Yes.
Yeah, 7x,
Yes.
minus 14 or negative 14, minus 3x or negative 3x, and plus 11 or positive 11. It doesn't matter whether it's an equation or it's an expression. If you have some like terms, you can combine them as long as they're on the same side of the equal sign, right? You try to jump across the equal sign, now you're going to be in trouble. But if I'm just working with the expression on the left-hand side, I sure can combine. So do you see any like terms here?
Yes, 7x minus 3x. And of course, that's 4x.
Beautiful. You just made that a little simpler. Do you see any other like terms that can combine?
Well, negative 14 and plus 11.
Exactly. And don't let your eyes skip over the equal sign. When we're simplifying, we only work on one side of the equal sign at a time. Beautiful. So negative 14 plus 11?
That's negative 3.
Gorgeous. And now you've just made that left-hand side of that equation a whole lot simpler. And now that simpler expression is going to be equivalent or equal to negative 1.
That's amazing.
That's so much easier. Simplify before you solve, right? Pack before you move. And now this is easy to solve. This is a 2-step equation like we've done before. Now, we are flipping into the world from simplifying to solving. So remember, we simplify by obeying the symbols on one side. We solve by doing the opposite, disobeying the symbols on 2 sides. So I want to work now to get X alone. There's no more straightforward math to do. It's time to start being disobedient.
Oh, wow. I would have left that alone.
Yeah, you would have thought there's nothing else I can do here.
Right.
The difference between these problems and the other problems is the equal sign. I have the power to figure out what X is.
Okay.
I didn't have equal signs on all the other ones. I only had the power to just do this forwards math, and then I had to stop. I had no clues before. We're going to use that clue there. We're going to start working backwards, okay? So how I'm going to do that is I'm going to work to get X alone. And remember, when we're solving, we work the order of operation backwards. So we should move anything adding or subtracting first. So I'm going to take away this subtract 3 by adding 3. Now, this will mess with students because we've been obeying the symbols up till now, but we've been working on an expression. Now we're working on the whole equation. And so we can be disobedient as long as we do it to both sides, jump across the equal sign. Let's see what will happen when we do that. Subtracting 3 and adding 3 are opposites. They'll cancel. 4x will be left, and that'll be equivalent to.
And I've got 2.
Gorgeous. Almost done, but x is not alone.
Okay.
X has a 4 out front. It's multiplying, so I will do the opposite. I will divide. Can I be disobedient? Yeah, as long as you do to both sides. That's why you needed an equation. Multiplying by 4 and dividing by 4 cancel. X is all alone. And careful, that doesn't say 4 divided by 2. Don't change the order to make you comfortable. That is 2 divided by 4.
0.5?
0.5. Now it feels real wrong, but that's real right, okay? If you take only $2 and you divide it between 4 of your friends, you guys are all going to end up with 50 cents. You don't end up with a lot of money when you take only a couple of dollars and you divide it up among a lot of people. But the GED will be multiple choice in cases like this. It could be a fraction as well. So I just want to show you something. So 2 divided, if I use the divided by sign, 4 gives me 0.5. But what if the answers were fractions? Well, hit the button right above enter. That's the quick convert button. And you can see that's the same as 1/2. You say, well, which one's right? And I say, yes. They're both equally as good. You'll never see both in the multiple choice because one's not better than the other. But either one could be there. So if you get one and they have the other, you better know how to go back and forth, whether it's in your calculator or by hand. So because a lot of times we can simplify an equation before we solve, we could see combining like terms come up in solving equations. Happens all the time. Okay, so let's look at example 11. And I just want to assure you guys that this is actually probably above the level of what you'll see on the GED. However, the 2 skills that we're looking at here, finding perimeter and combining like terms, both happen on the GED. So it's good review and also it's good college prep. So let's take a look. It says find the simplified perimeter of the rectangle. Now, my advanced level students know that perimeter is distance around the outside of a shape. Now, the distance might be ugly, but we can see, like, for example, that side of the shape is 3x minus 1. But we don't just want that side. We want to walk all the way around. Now, if these were plain old numbers, what would you do? You'd say, well, I walked 500 feet and then 300 feet and then 500 feet and then 300 feet, and you just add up those numbers. Well, even if the numbers are ugly, you can do the same thing. You can say, I walked 3x minus 1. Whatever that means, that's how far I walked. And plus, I'll walk 2x plus 5. You just made it partially around your rectangle. You went that part and you went that part. But careful, perimeter isn't going to suddenly change because my numbers got uglier. I got to get all the way around the rectangle. So I also have to go on this part of the block. Scary. What would that number be? Well, rectangles haven't changed either. Okay, so don't freak out just because the numbers got uglier. Just like when we had a rectangle that was 7 inches over here, it'd be 7 over there. If this one is 3x minus 1 over here, guess what?
You're right, 3x minus 1.
Exactly. Rectangles haven't changed. Perimeter hasn't changed. So I'm going to add in 3x minus 1. Now get all the way around the block. How long is that last side going to be?
That's 2x plus 5.
Sure is. And so I'm going to add in plus 2x plus 5. Sorry about this expression being too long, but that's okay. I just added up the 4 sides. And now it's not a word problem. It's not geometry anymore. All it is some like terms to combine. If I have any like terms, I can put them together and make this sucker a little simpler. So here, there's an x term, plus another x term, plus another x term, plus another x term. So 3 plus 2 plus 3 plus 2. What do we get?
10x.
Beautiful. 10, and they were just x's. They'll still be x's. And now those other numbers, well, those are all constants, right? Those are all plain old numbers. Minus 1 plus 5 minus 1 plus 5.
8.
And is that positive 8 or negative 8?
Positive 8.
Good. So I'll write plus 8. And now I'm done. That is the simplified perimeter of the rectangle. Can't get any simpler because I don't know what x is.
Well, now it's asking if the perimeter equals 78, solve for x. So
amen. Now it's saying if the perimeter equals 78, solve for x. Let's do it, girl. If the perimeter, which we know what the perimeter is, we said it was 10x plus 8. So if that perimeter we just found equals 78, solve for x, now we have a clue. Now we have an equal sign. Now we have an equation. Now we can solve a mystery. It's not until you get an equation that you can solve mysteries. And to solve our mystery, we need to get x alone on his side of the equal sign.
So our positive 8 will turn into a negative 8?
Good. We will do the opposite of adding 8 by subtracting 8. And we can do that as long as
we do it to the other side as well.
Beautiful. It's only because you have an equation that you can do this. So don't you be doing it on one side like it's legal. So it's only legal if you keep your equation balanced.
We have 70, and we're going to bring down the 10x.
Good.
And there's our equal sign. Now what we're going to do is get x alone. So that means I have to divide.
Bingo. Divide by exactly what you want to get rid of. That's the 10. And that's legal if and only if
we do it on the other side as well.
Gorgeous. We got to keep our two expressions equivalent. And then my new equation will be
X equals 7.
gorgeous.
Whew, that wasn't hard at all. I looked at it and got frightened.
I mean, literally. I feel like becoming a good algebra student from a struggling algebra, about 90% of it is quashing down that panic. And that panic comes up because we don't know what X is. But half the times we don't have to know what X is. And the only times we have to figure out what X is, we'll have the power to do so. We'll have that two-sided equation where we're allowed to do opposites. If we don't, well, we don't have to figure out what X is. It was never put on us. We just wrote an equation from a word problem and then we were able to solve it. So look, that's 3 GED skills in one. We have those geometry perimeter skills. We have combining like terms. We had writing equations. Oh no, and then solving equations. 4 GED skills we just reviewed. So if you feel like, ooh, that was challenge mode, that was challenge mode. We just put together 4 skills. But we really do need to graduate to that stage on the GED where we're actually able to put our skills together and not only able to practice 1 skill at a time. There's very few problems on the GED that are 1 skill at a time. They love to combo them up.
That was really a beautiful algebra problem. I really like that one.
Yay! It's good when you leave smiling instead of crying. All right, you guys, super proud of you. You did great work. We did some challenging examples today, but as Miss Annette pointed out, when you just look at it 1 step at a time, not that confusing after all. So make sure, though, that you go practice. It's always easy when the math teacher does it. But if you don't get that experience of going, wait, what skill do I need now? Before you test, you're going to be in trouble. So practice, 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 and we'll see you next class.